Welcome to one of the most mind-blowing manufacturing facilities on the planet, where giant aircraft literally come to life. Piece by piece, I'm taking you inside Europe's most advanced Airbus factory. And trust me, you're going to witness some seriously incredible automation and engineering that'll make your jaw drop. So buckle up, because we're about to explore how these massive flying machines are assembled from thousands of components into the beautiful aircraft that carry millions of passengers across the skies every single day. And honestly, the scale of this operation is something you have to see to believe. Our journey begins at the heart of Airbus production in Toulouse, France, where the magic truly happens. This isn't just any factory. This is where innovation meets precision on a scale that's hard to even imagine. We're talking about facilities so massive that they have their own weather systems inside. Yeah, you heard that right. The process kicks off with the fuselage sections arriving from different manufacturing sites across Europe. These enormous cylindrical sections travel by ship barge and even specialized transport aircraft called the beluga, which honestly looks like a flying whale. It's pretty hilarious, but incredibly efficient. Watch how these beluga aircraft land carrying fuselage sections that weigh several tons each. The precision required here is absolutely insane, because even the slightest damage during transport could compromise the entire aircraft's structural integrity. So everything is cushioned, monitored, and handled with extreme care. As the fuselage sections arrive at the main assembly hall, they're carefully unloaded using specialized lifting equipment. These aren't your average cranes. We're talking about computer-controlled systems that can position components within millimeters of accuracy. The technology here is absolutely next level. Now here comes the fascinating part. The fuselage sections are moved into position using automated guided vehicles, or AGVs. For short, these smart machines navigate the factory floor autonomously, following magnetic strips embedded in the concrete. It's like watching a carefully choreographed dance of massive components. The first major assembly stage involves joining these fuselage sections together. And this is where things get really interesting. Specialized jigs hold each section perfectly in place, while robotic systems drill thousands of holes. With pinpoint accuracy, we're talking about precision down to fractions of a millimeter. Here, those holes you're seeing aren't random. Each one is precisely calculated and positioned because that's where the rivets will go to hold the entire aircraft together permanently. Did you know a single Airbus A380 uses more than 6 million parts, including over 1 million fasteners? That's absolutely crazy when you think about it. The riveting process is equally impressive. Automated riveting machines work alongside skilled technicians to secure the fuselage sections together. Each rivet must meet exact specifications for strength and reliability, because there's literally zero room for error when you're building something that'll fly at 350,000 feet. Moving on to the wing assembly, which happens in a separate dedicated facility. Wings are arguably the most critical component of any aircraft. They generate lift support of the engines and house the fuel tanks. So the engineering and manufacturing standards here are off the charts. The wings arrive as complete assemblies from production facilities in the UK, and they're absolutely massive. A single wing for an A350 weighs around 15 tons and spans over 30 meters. That's longer than most swimming pools. And watching them being transported and installed is genuinely breathtaking. Here's where it gets even more impressive. The wings are lifted into position using overhead cranes that can handle weights exceeding 20 tons with absolute precision. The alignment has to be perfect within tolerances measured in fractions of a millimeter, because any misalignment would affect the aircraft's aerodynamics and performance. Once positioned, robotic systems begin the intricate process of attaching the wings to the fuselage. This involves hundreds of connection points, each requiring specific torque settings and inspection protocols. The robots work in perfect synchronization with human technicians, creating a beautiful harmony of man and machine. The electrical systems installation comes next, and this is mind-blowing in its complexity. Modern aircraft like the A350 contain over 530 kilometers of electrical wiring. That's enough to stretch from Paris to Stuttgart, If you laid it out in a straight line, absolutely insane, right? Specialized teams thread these wire bundles through the fuselage following exact routing diagrams. Every single wire is labeled color-coded and tested multiple times. To ensure perfect connectivity, the organization required here is something else, because one misconnected wire could cause serious problems down the line. Now let's talk about the cockpit installation, which is basically like installing the brain of the aircraft. The cockpit arrives as a pre-assembled unit containing all the flight instruments, displays, and controls. This modular approach saves enormous amounts of time during final assembly. Watch how carefully they lower the cockpit section into place using precision lifting equipment. The fit has to be absolutely perfect, and all the electrical, mechanical, and hydraulic connections must align flawlessly. It's like completing the world's most expensive and complex jigsaw puzzle. The hydraulic systems come next, and these are crucial because they control everything, from the landing gear to the flight control surfaces. Aircraft hydraulic systems operate at pressures exceeding 3,000 psi, so every connection, seal, and component must be absolutely perfect. Teams of specialists carefully install miles of hydraulic lines throughout the aircraft. Each line is pressure tested individually, and then the entire system undergoes rigorous testing to ensure there are no leaks or weak points. The attention to detail here is absolutely remarkable. Moving to the interior installation, where the aircraft starts to look like something you'd actually want to fly in. Seats, galleys, lavatories, overhead bins. Everything gets installed with military precision. The layout varies depending on which airline ordered the aircraft, so flexibility is key. These automated systems help position the seat tracks perfectly, ensuring every seat will be aligned correctly. The tracks are then secured with high-strength bolts, and the entire installation is inspected. Multiple times, airlines are very particular about their cabin layouts, so everything must meet exact specifications. The galley installation is equally fascinating. These compact kitchens contain everything needed to prepare and serve meals to hundreds of passengers. They're basically engineered to maximize functionality in minimal space, and watching them being installed is like observing a three-dimensional puzzle coming together. Overhead bins are installed next, using specialized equipment that ensures perfect alignment and secure. Mounting each bin must support significant weight and withstand the forces experienced during flight, including turbulence, so the installation standards are incredibly strict. Now we move to one of the most critical phases, engine installation. The engines arrive from manufacturers like Rolls-Royce or General Electric as complete units ready to be mounted. These incredible machines each cost millions of dollars and represent the absolute pinnacle of engineering achievement. Watch how the engines are carefully positioned under the wings, using specialized cradles and lifting equipment. The precision here is absolutely crucial, because improper mounting could lead to vibration issues or even catastrophic failure. The mounting points must align perfectly with the wing pylons. Each engine is secured using massive bolts that are torqued to exact specifications using computer-controlled tools. These tools ensure every bolt receives precisely the right amount of tension, not too loose and not too tight. It's engineering precision at its absolute finest. The fuel system installation is next, and this is incredibly complex. Modern Airbus aircraft have multiple fuel tanks distributed throughout the wings, and sometimes the fuselage storing tens of thousands of liters of jet fuel. The system must be completely leak-proof and operate flawlessly. Specialized technicians install the fuel lines, pumps, and sensors that make up this critical system. Every component is tested individually, and then the entire system undergoes pressure testing and leak detection. Using advanced electronic sensors, you cannot afford any mistakes here whatsoever. Landing gear installation is another crucial milestone. These massive assemblies must support the entire weight of the aircraft during takeoff and landing, absorbing enormous forces in the process. Each main landing gear unit on an A380 weighs over 4 tons and can support loads exceeding 200 tons. The landing gear bays are precision engineered to accept these assemblies, and the installation process requires perfect alignment. Automated systems help position the gear, while technicians secure it. Using high-strength bolts and locking mechanisms, the tolerances here are incredibly tight. Now comes the really cool part. The first power-up, where the aircraft's electrical systems are energized for the first time. This is a major milestone because it allows technicians to begin testing all the electronic systems, instruments, and computers that make modern flight possible. Banks of computers monitor every electrical circuit during this initial power-up. Looking for any anomalies or issues, it's like watching the aircraft wake up for the first time. As displays light up, systems initialize, and the cockpit comes alive with information. It's genuinely exciting to witness the flight control systems undergo extensive testing. Next, these systems are absolutely critical because they allow pilots to control the aircraft's movement through the air. Every control surface is cycled through its full range of motion, while sensors verify proper operation. Modern Airbus aircraft use fly-by-wire technology, meaning pilot inputs are transmitted electronically, rather than through mechanical cables. This requires incredibly sophisticated software and redundant systems to ensure safety. The testing procedures are exhaustive, and nothing is left to chance. Hydraulic system testing follows, with technicians pressurizing the entire system and checking every connection, joint, and component for leaks. Special fluorescent dye is sometimes added to the hydraulic fluid, making even the tiniest leaks visible under ultraviolet light. It's fascinating to watch. The environmental control system gets tested. Next, this system is responsible for maintaining comfortable temperature and pressure inside the cabin, while flying at altitudes where the outside air is deadly cold and too thin to breathe. Getting this system right is absolutely essential for passenger comfort and safety. Now we move outside to the paint shop, where the aircraft receives its distinctive livery. This is where the plane gets its identity, taking on the colors and branding of whichever airline ordered it. And honestly, watching a bare metal aircraft transform into a beautifully painted masterpiece is incredibly satisfying. The entire aircraft gets cleaned and prepared for painting, with surfaces carefully masked to protect areas that shouldn't be painted, like window sensors and specific markings. The preparation work is meticulous, because paint quality depends entirely on proper surface prep. Automated painting robots apply the base coat with remarkable precision. These robots are programmed with the exact dimensions of the aircraft and can apply paint with perfect consistency and coverage. The technology here ensures a flawless finish while minimizing waste. The airline's livery gets applied next, often using a combination of robotic painting and skilled manual work for detailed logos and designs. Watching the tail get painted with an airline's logo is genuinely mesmerizing, as the aircraft's identity truly comes together. Did you know the paint on a large aircraft like an A380 weighs around 500 kilograms? That's like adding the weight of a small car, but it's necessary for protection against corrosion and UV damage. Plus, it makes the aircraft look absolutely stunning. After painting, the aircraft moves to the flight test preparation area, where it received its final systems checks before its maiden flight. This includes installing test equipment and instrumentation that will monitor every aspect of the aircraft's performance during flight testing. The fuel tanks are filled for the first time, which is a significant event, because it allows technicians to verify the fuel system works correctly under actual operating conditions. Specialized trucks pump thousands of liters of jet fuel into the tanks, while sensors monitor for any issues. Now comes one of the most exciting moments, the engine run-up tests, where the engines are started and operated for the first time, while the aircraft is still on the ground. The sound is absolutely incredible, as these powerful turbofans roar to life, generating thrust that will eventually lift this massive machine into the sky. Technicians monitor hundreds of parameters during engine testing, including temperatures, pressures, vibration levels, and thrust output. Everything must fall within acceptable ranges before the aircraft can be cleared for flight. The data collected here is absolutely critical. The landing gear undergoes dynamic testing, where hydraulic systems extend and retract the gear repeatedly, while sensors verify proper operation. This might seem simple, But the landing gear system is incredibly complex, with multiple redundancies and safety features. Brake testing follows, with technicians verifying the brake systems can generate enough force to stop the aircraft, even in emergency situations. This involves pressurizing the brake system and measuring the clamping force on each wheel. The requirements here are incredibly stringent. Flight control surfaces are tested extensively, with ailerons, elevators, and rudders moving through their full range, while sensors verify smooth operation and proper response. These controls must work perfectly, because they're essential for safe flight. There's absolutely no room for error. The avionics systems undergo comprehensive testing, with technicians verifying every display instrument and computer operates correctly. They simulate various flight conditions and emergency scenarios to ensure the systems respond appropriately. It's incredibly thorough testing. Now we approach the most exciting phase, the first flight, where this magnificent machine finally takes to the skies for the very first time. This is what all the months of work have been building toward, and the atmosphere in the factory is electric with anticipation. A specially trained test crew boards the aircraft, including experienced test pilots and flight engineers carrying sophisticated monitoring equipment. They'll evaluate every aspect of the aircraft's performance during this crucial maiden voyage. The engines spool up and the aircraft begins its taxi to the runway. This is genuinely emotional for everyone involved, because hundreds of people have worked thousands of hours to reach this moment. Watching it actually move under its own power is incredibly powerful. The takeoff is breathtaking as the aircraft accelerates down the runway and lifts gracefully into the air. For the first time, the test pilots evaluate the handling characteristics, while onboard systems record massive amounts of data about the aircraft's performance. During the flight test, pilots put the aircraft through various maneuvers, testing its response to control inputs, stability, and overall handling characteristics. They're looking for any issues or anomalies that need addressing before the aircraft enters commercial service. After several hours of testing, the aircraft returns for landing, which is always a tense moment. Even though everyone is confident in the aircraft's capabilities, watching it touch down smoothly is met with cheers and applause throughout the facility. The flight test data is downloaded and analyzed immediately, with engineers poring over every parameter, looking for anything unusual or unexpected. This analysis helps validate the aircraft's design and identifies any adjustments needed before delivery. The aircraft then undergoes additional flight testing, including longer duration flights, testing of specific systems, and validation of performance specifications. These test flights might continue for weeks, ensuring everything works perfectly. Any issues discovered during testing are addressed immediately, with technicians making adjustments or replacing components as needed. The goal is to deliver an aircraft that meets every specification and performs flawlessly. As testing concludes, the aircraft receives its final certification documentation, confirming it meets all regulatory requirements and is safe for commercial operation. This is a major milestone, because without certification the aircraft cannot enter service. The interior receives its final detailing, with seats cleaned overhead, bins inspected, and every surface polished to perfection. The aircraft must look absolutely pristine. When delivered to the customer airlines, expect perfection. And that's exactly what they get. Final inspection teams walk through the entire aircraft, checking every system surface and component against detailed checklists. Nothing is overlooked during this comprehensive examination. It's the last opportunity to catch any issues before delivery. The aircraft is then prepared for its delivery flight, which is often a special occasion with airline representatives present to take official possession of their new aircraft. It's a proud moment for everyone involved in the manufacturing process. Watching the finished aircraft taxi away on its delivery flight is genuinely emotional. After witnessing the incredible journey from separate components to a fully functional flying machine, you can't help but feel amazed by what human ingenuity can achieve. The entire process from start to finish typically takes several months, depending on the aircraft model and customer specifications.
She's
but
a beauty,
every
isn't she?
single minute is focused on creating
Absolutely
the
exceeded
safest,
all
most
expectations.
advanced aircraft possible.
A new-
Modern Airbus facilities can produce several aircraft simultaneously at different stages of assembly, creating a constant flow of new aircraft rolling off the production line. It's manufacturing efficiency at an incredible scale. The level of automation continues to increase with new robotic systems and AI-driven quality control being implemented constantly. Airbus is always looking for ways to improve efficiency while maintaining the highest quality standards. What you've witnessed today represents the absolute pinnacle of modern manufacturing, engineering, and human achievement. These
The
aircraft
precision in
will
this
serve
assembly
airlines
is
for
critical.
decades, carrying
Agreed.
millions
Every
of
component
passengers
has to be
safely
perfect.
to their destinations all over the world. I hope you've enjoyed this incredible journey through the Airbus assembly process. If you found this fascinating, please hit that like button. So we know you want to see more amazing factory content like this. We've got tons of other manufacturing videos covering everything from food production to automotive assembly. So make sure you check those out, and don't forget to subscribe, because we're constantly creating new content. The precision, the technology, the skill, and the dedication required to build these magnificent flying machines is truly inspiring. And I'm so glad I could share this experience with you today. Thanks for watching, and remember, every time you board an aircraft, think about the thousands of people and countless hours of work that went into creating that incredible machine that defies gravity and connects our world. Until next time, keep being curious about how things are made, because understanding these processes helps us appreciate the amazing world of manufacturing that makes modern life possible. We'll see you in the next video.